So today I'm looking at the contains duplicate problem in LeetCode. And this problem is given an integer array nums, return true if any value appears at least twice in the array, and return false if every element is distinct. So what we need to do is check over our array of numbers, and if we see that there is a duplicate, like 1 in this one, we return true, and if we don't find a duplicate, we return false. The data structure that's going to work best for us here is a set, which contains unique values. And we can do a quick lookup. We can do a contains. We can check if a set contains a certain number very quickly, and that will help us find duplicates. In our solution, we're going to be using a set to, we're going to iterate over our numbers, and we're going to add them to a set. And then we can use that set for later numbers and check if our set contains the value already, in which case we found a duplicate and we can return true. Otherwise, if we iterate through our entire array of numbers and we add them all to our set and find that nothing is duplicate, then we can just return false. So in C#, which is what I'm using, a set is a hash set, and we can call that unique nums. And we can set that equal to just square brackets. Otherwise, it would be new hash set int and then open and close parentheses. And then we simply sweep over our array of numbers, going up to just below the length of our array. And if our set contains the number we're currently looking at, then we know we found a duplicate. So we return true. Otherwise, we add the number to our array. Because I've indexed this twice, I might actually pull this out. So this will be our int current number, and that can be used here instead. And also here. And at the end, we return false if we haven't found anything. If we haven't hit this condition and returned, then we haven't found any duplicates, and we can return false. So just double checking over this, it looks like that'll work. Looks like I've stuffed up somewhere. So if I'm not adding, I need to add, and then we should be good. Cool. So before I submit, we'll submit and just make sure that it passes all our test cases. Cool. So middle of the pack, but I think this is a fast enough solution. It is because we have this for loop here, and everything contained inside it is a constant time, has constant time complexity. Then the big O of n of this method is the big O of this method is n, which just means that it's directly related to the number of elements coming in. And it's much better than n squared, which would be our naive solution here.